Hi, this is Miss McClellan here to go over IM2 Notes 5.1.3 with you. How can I sketch it without a table? Okay, we have two learning goals today. First, I will be able to draw a function using its intercepts. And I should have said a quadratic function. Period. And number two, I will be able to find the x-intercepts from standard form by factoring and applying the zero product property. And we begin. Problem 5-26 from page 269. How many points do you need in order to sketch a parabola? 1, 10, 50? Think about it as you answer the questions below. Part A. Can you make a sketch of a parabola if you only know the y-intercepts? For example, if the y-intercept of a parabola is 0, -15, can you sketch its graph? Let me think. Okay. 0, -15. Say this is 0, -15. Well, I can draw a parabola through that. But what if the parabola had that -15? This would also work though, and that's a different parabola. And you know what, that would work too. So I think the answer is no, because I need more info. Does it open up? Is it concave down? Where is its vertex? I need to know all of the important features of this graph, and the y-intercept is just one of them. Okay, well, let's think. What if we only know two x-intercepts? There's one option, but look, here's another. Not enough info again. We still need to know the vertex and y-intercept. Okay. So far, these questions are trying to get us to think about what the essential information is. Part C. Can you make a sketch of a parabola with two x-intercepts and the y-intercept? Okay, let's check. So suppose our x-intercepts are -3 and 0. I'm going to zoom in. Sorry, not -3 and 0. -3, 0, and 5, 0. Okay, so let's see. Counting by 2, so here's -3. And here's 5. And the y-intercept is 0, 15. So that's up above. And let's see, I need my line of symmetry. So it'll be like this. Yeah, I think that's enough. Although I would still like to know the vertex. But I know that the vertex is going to be above that y-intercept. So I know at least where the vertex is going to be in general. Closer. I still wonder where the vertex is. And later we'll find out, I should add, later we will find out that 3 points are indeed enough. Okay, next problem, 5-27. In the previous problem, we learned that if you know the intercepts of a parabola, then you can sketch its graph without making a table. All right, cool, but how do we find the intercepts of the parabola if we're given its equation? Let's think about it. First of all, what is true about the y value for all x-intercepts? Okay, suppose this is an x-intercept. I've got x, comma, y is 0. Y is always equal to 0 for x-intercepts. Similarly, everybody, on a y-intercept, x has to equal 0 for a y-intercept. Oopsie. X equals 0. Okay, I can use that information to solve things. So in the next problem, it says, what is the y-intercept of the graph y equals 2x squared plus 5x minus 12? Well, I want the y-intercept, and therefore I'm going to set x equal to 0. I have y equals 2, and we know how to solve for y when we know what x is. We've done it many, many times on our tables. We plug in our x value, and we solve for y. We get y equals negative 12. Therefore, the y-intercept is 0, because that's what x equaled, negative 12. Okay. What equation would I need to solve to determine the x-intercepts? Well, we want the x-intercepts, and therefore we set y equal to 0. And we have, instead of y, 0 equals 2x squared plus 5x minus 12. And that is not solvable with methods until today. Guess what, everybody? This is why we factor. Okay, check this out. The solutions to the equation 2x squared plus 5x minus 0 are called the zeros of the function. They're called zeros because x is 0 y equals 2x squared plus 5x minus 12. And at this point, can we algebraically solve it? Well, no. Because we have two unknowns in one equation. Essentially, x and x squared are like two different quantities, two different unknowns. You really can only have one unknown in a single equation. We have to change the way the equation looks in order to solve it. We're going to apply something called the zero product property. It is the star of the lesson. It allows us to graph. In order to use it, I need to factor this. So I'm going to factor this using the Xbox method. Oops. Okay. I start with my box, put 2x squared minus 12. I know the diagonals have to multiply to the same thing, so that's negative 24 x squared on top and 5x on the bottom. Okay. What are the factors of negative 24? Let me see. I've got negative 12 and 2. That's not it. 8 and negative 3 is it. So I've got 8x times negative 3x. 8x, negative 3x. And now I finish. Okay, greatest common factor of the first column. Okay, then we have 2x and negative 3 and 4. So x plus 4 times 2x minus 3 equals 2x squared plus 5x minus 12. Okay, part A asked us to do what we just did. Rewrite this equation in factored form. Although it's not just an expression now, it's an equation because it has the equal 0 part. So let's see, this is x plus 4 times 2x minus 3 equals 0. Now that it's in factored form, we're going to use the zero product property to factor it. We're going to use one factor at a time to determine what x value makes it equal to 0. And I think that's a lot to hold in our head, so I'm going to take us down to our math notes, and then we'll finish that problem after him. Okay, so here we have our math notes. The zero product property. Now, when the product of two or more factors is 0, at least one of those factors must equal 0. This is known as the zero product property. If A times B equals 0, then A equals 0, or B equals 0, or both. So for example, suppose we have 2x minus 3 times x plus 5 equals 0. Well then, 2x minus 3 equals 0, or x plus 5 equals 0, or both. And to find the possible x values, we solve each equation. So let's take 2x minus 3 equals 0. To solve that, I add 3 to both sides. I get 2x equals 3, divide by 2. I get x equals 3 over 2 as one of my answers. Okay, next, x plus 5 equals 0. I subtract 5 from both sides. I get x equals negative 5 as one of my answers. And that's how you do the zero product property. Once you've got something factored, you split it into two equations and solve both of them. Okay, let's keep going with this problem. So in this case, we have x plus 4 times 2x minus 3 equals 0, splitting this into two equations. I've got x plus 4 equals 0 and 2x minus 3 equals 0. Subtract 4 from both sides to solve this version. X is negative 4. Okay, add 3 to both sides. I get 2x equals 3, divide by 2. I get x is 3 halves. So we got two answers here. X is 3 over 2, or x is negative 4. Okay, with one more piece of information, we can sketch this graph. What's the y-intercept? Okay, so want y-intercept. I actually think we need two more pieces of information, and the next problem will take us to the vertex. But for now, I know that the text is asking us to find the y-intercept. Okay, want the y-intercept. That means we set x equal to 0. So we have y is equal to 2 times 0 squared plus 5 times 0 minus 12, which is just negative 12. All right. So from our y-intercept, we know that the point 0, negative 12 is on the graph. And from our x-intercepts, we know that the points 3 over 2, 0, that's 1.5, and negative 4, 0 are on the graph. Let's plot those. Okay, we've got 0, negative 12. I'm going to have this count by 2 just because I'm going to have the x-axis count by 2 just because the y-axis counts by 2. So let's see, negative 4 right here. And then 1.5. It's about here. Okay. And let's see. There's my graph. And I claim I also want to know the vertex, but we're going to keep going with these notes. Another useful point on the parabola is the vertex. How can we use the x-intercepts of a parabola to help locate the vertex? Okay, so first, let's use the zero product property to find the x-intercepts. Okay, let me see. So I'm going to factor that. Got x squared minus 5. Got negative 5x squared. I want to add to 4x. That's going to be 5x and 1x. Sorry, negative 1x. Okay, x, 5, negative 1. So to find my x-intercepts, I'm going to set this equal to 0. 0 equals x plus 5 times x minus 1. Split that up. X plus 5 is 0 if x is negative 5. X minus 1 is 0 if x is equal to 1. Therefore, my x-intercepts are at negative 5, 0, and 1, 0. Okay, Let's see. -5, 0, and 1, 0. Okay. Now I want to know the vertex. So I'm going to have to go exactly between these. So let's see. Where's the middle here? Is that at -2? Visually, I think it's at -2, but let me double check by averaging these x-intercepts. -5 plus 1 divided by 2, -4 divided by 2, which is -2. Yeah, so my line of symmetry is at x equals -2. Therefore, the vertex has to be on that line of symmetry. Let me solve for y in the vertex. It's going to be y equals, I know it's in the line of symmetry, so x has to be -2. -2 squared plus 4 times -2 minus 5. That's 4 minus 8 minus 5. And that equals -9. So my y-intercept is at 0, -9. I mean, sorry, not my y-intercept, is the vertex. Okay, so 0, -9. I think I did something wrong. 1 second. Yes, I definitely did something wrong. X is not 0. It's -2. See? Should have been -2, since that's what I plugged in. And that's the line of symmetry. And the vertex is on the line of symmetry. So the vertex is at -2, -9. It's right here. Okay. Now to plot this. We should really know the y-intercept. Y-intercept. Let's set x equal to 0. Y equals 0 plus 4 times 0 minus 5, which is -5. 0, -5. Right there. Okay. There. A perfect graph with all the features labeled and everything. Okay, so we went over the zero product property. That's how you're going to be finding your x-intercepts. Now let's just look at some really straightforward graphing examples. Graphing parabolas from standard form, and this is going to be the last page. So to sketch a graph, you can do some of these in different orders. First, you want to find the y-intercept. To find it, you replace x with 0 in the equation of the function and solve for y. So we are going to be doing this with the function above. Y equals x squared plus 4x minus 5. And we're replacing the x values with 0. You solve that and you get y equals -5. Therefore, the y-intercept is at 0, -5. Similarly, to find the x-intercepts, now you replace y with 0 and solve for x. In order to do that, you have to factor. So here we replace y with 0. Then we factor it. Now, I didn't show that, but let's do it right on the side. It's got x squared negative 5. You may see this is the same problem as the one we did before. 5x, negative 1x, x minus 1, x plus 5. So we write the problem in factored form, and we get 0 equals x plus 5 times x minus 1. And then we use a zero product property to split this into two equations. That's going to give us x plus 5 is 0, or x minus 1 is 0. And that gives us the x-intercepts of negative 5 and positive 1. So they're at negative 5, 0, and 1, 0. Then we need to find the vertex. First, we find the x-coordinate of the vertex. And in order to do that, we average the x-intercepts. We find the average, we should have said of the x-intercepts for any 2 points of symmetry. It doesn't have to be the x ones. Or we could use the formula x equals negative b over 2a, which I'm not going to emphasize in these notes, but some of you may prefer that formula. We'll start using negative b over 2a when we learn the quadratic formula. Okay, so averaging the x-intercepts. Our x-intercepts were at negative 5 and 1, so you can add those together and divide by 2. And I will show you the negative b over 2a method right now. Let's see. My function was y equals x squared plus 4x minus 5. A is 1. B is 4. C is negative 5. You can also find the x-coordinate of the vertex, the line of symmetry, by doing negative b, so negative 4, over 2a. So 2 times 1, that also equals negative 2. A separate method you can use if you like. Now we find the y-coordinate of the vertex. To find the y-coordinate of the vertex, we replace the x value in the equation with the value of the x-coordinate of the vertex. So our x value was negative 2. And so we plug negative 2 into our equation, and we get the result of y equals negative 9. And therefore the vertex is at negative 2, negative 9. Once we know the intercepts in the vertex, it's easy to graph the function. Shall we? Got negative 5, 0, 1, 0. Plotted those two pieces. My line of symmetry is at negative 2. Right down here. X equals negative 2. My y-intercept was at 0, negative 5. And my vertex was at negative 2, negative 9. Now you don't have to put the mirror point in, but for me it's easier, so I did. You try to make this curve as smooth as possible. That's my best curve. Okay, thanks for coming along with me. Hope you have a great night. Bye!